Okay, today we're going to talk about
the law of conservation of matter.
So here's a chemical equation, and you should be able to recognize these parts by now, the reactants and products and coefficients and subscripts, and know what those mean. So a chemical equation is just a description of what's going on in the chemical reaction. The key to this is, though, it must be written to reflect
the law of conservation of matter.
So now let's define what is
the law of conservation of matter.
Matter can't be created or destroyed, but it can be converted from one form into another. So here's a little pictograph of that. I have a bunch of blue dots and a bunch of black circles, and something happens and now they look like this. So on the left are the reactants, and so I have a combination of two blues, and that shows up twice. And then I have 2, 4, 6, 8, 10, 12 black circles showing up as a combination of twos. If I look up, then the arrow means a reaction is taking place. And then on this side, you can see I still only have 4 blue dots and 12 black circles, but they're arranged in a different way. So bonds have broken and reformed to form a new substance. Okay, so let's take a look at this and refer back to counting atoms. Let's make the assumption that the double blue dot is nitrogen gas, which is N2. The double black circle is going to represent hydrogen gas, which is H2. The single blue dot with the 3 black circles is NH3, which is actually ammonia. So let's put that into the chemical equation. Now we have to look at the numbers of atoms. So we're going to draw the T-chart, a T-chart with the vertical part of the T under the yields arrow. And we're going to list the atoms that show up on either side of the arrow. So for the reactants, we have nitrogen and hydrogen. And then we go over to the product side, and we also have nitrogen and hydrogen. And that needs to be true. They should be, the type of atoms should be identical on both sides. So now let's go back and count. If we look at that subscript of the 2 for the nitrogen, we know we have 2 atoms of nitrogen. Same thing with the hydrogen, we have 2 atoms of hydrogen. And you can see that up in the pictures as well. Going over to the product side, we have 1 atom of nitrogen and 3 atoms of hydrogen. Somehow we went from having 2 atoms of nitrogen to only 1. Somehow
matter was destroyed.
Now let's look at the hydrogens. Hydrogens went from 2 atoms to 3 atoms, so somehow
matter was created.
And that can't happen. Okay, so this equation does not reflect
the law of conservation of matter.
So let's just take a look at that picture that we looked at before. So we had the reactants and the products, and the elements and the number of atoms have to be the same on both sides. So we can look up there and we can see, well, there are 2 combinations of blue in the first part, 6 combinations of 2 black circles in the reactants, and then when we get over here, we have 4 combinations of NH3. So now let's go back. So they're not the same. So that's a problem. So how do we fix it? The only way to fix it is to change the number of particles that you start with and end with. And the only way to do that is by changing the coefficients. You may not ever change the subscripts, because if you change the subscripts, you change what the substance is. Coefficients just tell you that you have more or less or greater or fewer particles than you did before, but it doesn't change what it is. So do not change the subscript. Hard and fast rule. So now let's look at this. So we know that
the law of conservation of matter
is not represented here. So we look back and we had 2 N2s, we had 6 H2s, and we had 4 NH3s. So what I'm going to go and do is put those in as coefficients down in the equation. So now let's recount the atoms. So I have a molecule of N2, and I have 2 of them. So I say 2 times 2. So now I have 4 nitrogen instead of just 2. With this coefficient of 6 in front of the H2, 6 times 2, I now have 12 H's. Then I go over here, 4 times 1 for the nitrogen is 4, and 4 times 3 for the hydrogen is 12. So now this equation does illustrate
the law of conservation of matter.
So looking at our equation from before with the sodium and the water, the reactants have to equal the products, the numbers and types of atoms. So we have sodium, hydrogen, oxygen, same thing. Now, notice that the appearance of these atoms is not in the same order. It's sodium, oxygen, hydrogen. I highly recommend you always list them in the same order, regardless of the order in which they show up. So we have 2 sodiums over here. We have 2 times 2 is 4 hydrogens. 2 times 1 is 2 oxygens. And over here, 2 times 1 is 2 sodiums. 2 times 1 is 2 oxygens, but let's go to the hydrogens. 2 times this one is 2, plus the 2 for over here, so that's 4 and 2. And there you have it. No atoms or matter were created or destroyed. And that is
the law of conservation of matter.
I just want to do a couple of examples with you before you go on to do the Kahoot. So we have this first formula unit, K2CO3, and we're going to have 4 of those. So the K2CO3 is its own particle, right? It's a formula unit. When you look at the 4 out front, remember that's how many particles you have. So when you're counting, the 4 applies to every element within that particle. The subscripts, however, only apply to the element that they're immediately after. Okay? So for the potassium, we have 4 times 2 is 8. For the carbon, we have 4 times 1 is 4. And for the oxygen, we have 4 times 3, which is 12. Now, there's another situation that you may run into where you have parentheses within the particle. So in this particular case, the combination of PO4 shows up twice within the one particle. So the 2 outside the parentheses applies to any elements within the parentheses, and the 2 out front applies to every atom within that particle. So strontium, we're going to have 2 times 3, which is 6. For phosphorus, we're going to have 2, 2, 4. And for oxygen, we're going to have 2 times 4 is 8, times 2 is 16 oxygens.